of the session. So, the first thing is that I plan to do two separate discussion, one from in Sinhala language and other is from Tamil language. Okay, so very soon I will arrange that. Okay, I hope today also all students are. Okay, I will check. Hello, hello, hello. So can you hear me now clearly? Utika, now is it okay? Or is still not clear?
Yeah, sir, clear. No
It
problem.
is okay. Okay, thank you. So the first thing is that I hope to arrange two sessions separately. One in Sinhala and other one is from Tamil. Okay, so I will get help from Tamil student, senior student. I think to understand the subject, maybe the language also may be an issue. No? So I will do that for you. Okay. So I need so who is your what is called the representative? That representative is he with us now? Anyway, I need time slot, free time slot, okay, for you to arrange that discussion. Okay, I think it will be very important because I hope to do it one from Sinhala and other is from Tamil. So how I get your feedback? I need one coordinator. So I think you have a batch representative, no? Can someone talk with me, please? Otherwise, I can't get the information from you to arrange that session. Okay, you guys can discuss and tell me the possible date and time. Okay, I need several possible date and times. Otherwise, that times and date also that I and that Tamil student also should be free in that time slot. So I need two or three time slot from you. Then I will arrange. If I didn't get feedback from you, I will arrange it in our normal class discussion. Okay. So that is the information that I want to give you. Okay, we will start. Okay. So I think now I hope you can see my screen. No? You can see my shared screen. Okay, thank you. Okay, so now we have completed our learning outcome one. Okay, learning outcome one, we already completed it. Okay, so can anyone tell me what are the things we have learned in LO1, learning outcome one? Can anyone tell me? Okay. Dhananj, can you give, okay, can you drop me an email?
හෙලෝ සර් මේ අපිට කරන්ට් එක නැහැ මේ කනෙක්ෂන් අවුල් ඒ නිසා මට ලොග් වෙන්න බැරි වුණා.
හරි කමන්නේ මට අර පොඩ්ඩක් ඔයාව කන්ටැක්ට් කරගන්න ඕන මම හිතන්නේ කට්ටියට අර සෙපරේට් සෙෂන් දෙකක් අරේන්ජ් කරන්න එකක් තමිල් වලිනුයි සිංහල වලිනුයි සිංහල එක නම් මටම කරන්න පුළුවන්. අනිත් මම දන්නේ නැති හින්දා මම එකට අර ස්ටුඩන්ට් කෙනෙක්ගෙන් හෙල්ප් එකක් ගන්නවා. ඔය කට්ටිය සීනියර් කෙනෙක්. ඒක අරේන්ජ් කරගන්න ඔය කට්ටියට ෆ්‍රී අපිටත් ෆ්‍රී ටයිම් ස්ලොට් දෙකක් අරේන්ජ් කරගන්න ඕන.
එතකොට සර්ට අපේ ෆී ඩේට් එකක් දානවා.
ඔව් ඩේට් එකක් කියන්නේ මම මෙහෙමයි. මම පොඩ්ඩක් එහෙම වුණත් ඔයාට මේල් එකක් දාන්න අපිට පොසිබල් දවස් ටික. ඔය කට්ටිය ඒකෙන් සිලෙක්ට් කරලා එවන්න මේ ටයිම් ස්ලොට් එකක්. හරි.
හරි සර්. සර්ගේ මේල් එක මට දෙන්න පුළුවන්ද?
පුළුවන්.
හරි සර්. සර් මේ ටෙස්ට් එකක් දානවද නැත්නම් දැන් කියනවද?
නොටිස් චැට් එකට දාන්න.
හරි සර්. හරි. thank you.
Okay. So I have sent my email address. Okay. Okay.
Okay sir. thank you.
Okay. Okay, now we will move to our session. Okay. So can anyone tell me what have we learned in our LO1, learning outcome one? මොනවද අපි learning outcome one වල ඉගෙන ගත්තේ? So I think I have repeated this several times. So we have learned about some basic type of signals. Yeah, signal classification. Thank you. So so under signal classification, we have learned several types of signal. Okay, the random signal, deterministic signal, periodic, non-periodic signal. Okay, and continuous and discrete signal, and finally we have learned even and odd signal. No, even and odd signal. Okay, so we know that our course is based on deterministic signal. Okay, deterministic signal, and it is continuous time. Okay, continuous time signals. Okay, so so I think now semester exam is very near. Okay, so I will put some questions for mid exam. Okay, in periodic signals and odd annual signals. Okay, so from these two sections you will get some questions. Okay, so please go through this again, and you have to have a good idea about these signals, these type of signals. Okay, so so I think now you can find, now you should be able to find the period of any periodic signal. Okay, you should be able to find the period of any periodic signal. Okay, it may be a composite signal. Okay, composite signal, or it may be any kind of periodic signal. Okay, now I hope you should be able, okay, you are able to find the period of any signal. Okay, and also you should be able to find on an even component of a signal. If we give a signal, okay, signal, you should be able to find the odd component and also even component. Okay, this is the odd component, and this is denoted by the odd component is denoted by this XOT, and this is XET. Okay, so you should be able to find these two component if I give you a signal. Okay, and also you should be able to draw a signal. Okay, draw any sine wave. Okay, draw any sinusoidal signal. If I give you the signal expression, for example, if I give you this kind of signal, 2 cos 50t plus 90, like somewhat like this. So you should be able to draw this. Okay, you should be able to draw this by your hand. Okay, marking the important points, important time values, and important amplitude values. Okay, so now you should develop those skills with yourself. Okay, and also we have learned some basic type of signal. No, can anyone tell me what are the types? What are the basic signals we have learned? Basic signal. We have learned 4 types of basic signals. No, actually not types. Okay, 4 basic signals, the important signals. What are they? I expect your feedback actually. Can anyone give a feedback? What are the basic signals we have learned? First, we have learned sinusoidal signal. No, sinusoidal signal. Sinusoidal signals. Okay, and we have found the period of a sinusoidal signal, and we have proved that. Okay, using the condition for periodicity. So I hope you can remember those things. And what are the other signals we have learned? Please, someone feedback? Can you remember? What are the other signals we have learned? We have learned unit step signal, no? Unit step signal, and unit impulse signal. And we have discussed some properties of these signals. Okay, and also we have learned exponential signal, no? Exponential signal. Okay. So under exponential signal, we have learned again two types of signal: real exponential signal and complex exponential signal. No? Can you remember? Okay. So in real exponential, we have the decaying signal and increasing signal like this. Okay. And for complex case also, we come across these two, no? Decaying and increasing signal like this. Okay. So please refer that previous lectures, and also please refer your note, and please get understand about this. Okay. So from here also, I hope to give one or two questions regarding the unit step signal. Okay. So I have told you how to approximate any signal using the unit step signals. No? Using weighted unit step signal, we can approximate any signal. Okay. We can approximate any signal using shifted and weighted unit step as a collection of shifted and weighted unit impulse signal. Can you remember? Okay. So any signals we can approximate in that way. Okay. So maybe you will get that kind of question also. Okay. I hope I have given the similar question in the tutorial. If you have gone through that tutorial, I think you have already come across these things. Okay. So please try to memorize these things. Okay. So in LO1, we have covered all these things. Okay. In our learning outcome 1. Okay. So now we can move to the learning outcome 2 actually. Okay. In learning outcome 2, okay, we are mainly learning. We are going to learn mainly the transformation of independent variable. Okay. Transformation of independent variable. So I have uploaded one the first lecture actually. Okay. Actually today I have uploaded bit. Okay. Because so I don't think you have enough time to go through that one, go through that lecture. Okay. So anyway, please go through it and try to understand what is this concept. Okay. So actually this is one of a key concept in signal processing. Okay. Because in many signal processing systems and for analytical purpose, we need to do this transformation, independent variable transformation. Okay. So can anyone tell me what is the independent variable we are mostly used for signals? What is the independent variable mostly we are using? Can anyone tell me? So what is the variable we choose for x-axis? This is the independent variable axis, no? So what is the variable normally when we are when we are dealing? Yeah, can't hear. Someone is talking. Okay, so what is the variable? What is here? Normally it is time, no? Okay, and also I told you that we can also use the frequency as the independent variable, okay, for signals. Okay, and this is a time domain signal, and this is frequency domain signal. Okay, so time is our independent variable in most cases. Okay, I can't say that in every cases time is the independent variable, but in most cases we are using time as the independent variable. Okay, related with signals. Okay, and also we use frequency as independent variable in frequency domain, but still we didn't touch this part. No, I think after 2 or 3 weeks we can go to this frequency domain representation. Okay, so still we are in time domain. Still we are in time domain. Okay, so this independent variable we can give another name, time transformation actually. This is time transformation. So actually here we are going to learn in LO2 the time transformation techniques. Okay, there we are going to use, we are going to learn 3 basic time transformation techniques. Okay, one is time shift, time shifting, time reversing, or sometimes we call it time reflecting. Okay, and the third one is time scale. Okay, so we are going to learn these 3 time manipulating or time transformation techniques. Okay. Okay. So now, so for your mid exam, also you will get the question from this area also. Okay. Time shifting and time reflecting and time scaling. In those 3 time manipulating techniques or time transformation techniques, you will get 1 or 2 questions. Okay, so you have to go through this also before your mid review exam, mid semester exam. Okay, okay, so we will do some yeah, I hope so. Most probably it may be online exam. Okay, but please don't copy. Okay, because I normally note that thing. Okay, you can do the exam by yourself as much as possible. Okay, then I can also understand your level actually. Okay, so so this is our LMS page actually. So I hope all the things the important things I have discussed in these recorded lectures. Okay, so you can go through it. Okay, as I told you, if you are not comfortable with these lectures, okay, you can use this tutorial. Okay, you can use this tutorial as a guide. Okay, and you can do your learning through this tutorial. You can, if you try to answer the question in this tutorial using other videos or other textbooks, I have given the 2 reference textbooks. Okay, so all the answers for all these questions are in those textbooks actually, primary and secondary textbooks. Okay, so you can use that textbook if you are not comfortable with my lectures, okay. So I hope now you have tried some of, at least some of these questions, okay. So if you have any problem related with this tutorial or the stuff we have learned up to now, you can ask now, okay. So do you have any question related with this tutorial, the things we have learned up to today? So if you want me to if you want me to answer any of any of any question of this tutorial, you can ask me to do, okay. If you are so, can you tell me what should I do? Okay, if yeah, tell me. Okay, I will. If you can't talk, okay, I will select one or two questions by myself and do. Okay. So what about this one? Anyone tried this question? So I think, I hope now you can find the period of any periodic signal, okay? Because I have done many examples in our previous classes, okay? So I hope now you don't have any question regarding this, okay? So if you have any question, please tell me, then I can do another one or two examples, okay? If you want me to do one or two examples related with this section, okay, you can ask. So all you are okay with this section, no? You can find the period of any signals. Okay, then I will go to this. So I hope now you should be able to do this kind of question also, okay? Using unit step signal, you can represent any staircase signal. So actually you can approximate any signal, any arbitrary signal you can approximate using shifted and weighted unit impulse signal. Okay, so you can see that this is one impulse and this is another impulse. Sorry, not impulse. Okay, step. Okay, so this is one unit step, and this is another weighted unit step, and it is shifted, and this one is also same. Okay, so this is a collection of weighted and shifted unit step, no, unit steps. So I think now you should be able to do this kind of question. So as I can remember, I have done this question in our tutorial, in our class discussion. Okay. So what about this one? May I do this, or can you do it yourself? This is regarding the odd and even signals, no? Please feedback. If you don't need, I can go to the next level, that time transformation. Okay. Actually, this I like this class discussion also. Discussion also used for this LO1 section. Okay. So, what is your feedback? Can anyone tell? Shall I do this or shall I move to the next level, time transformation? මේක කරන්න පුළුවන්ද මොකද කරන්නේ මම time transformation එකට යන්නද නැත්නම් මේක මොනවා හරි ගානක් හදන්න ඕනද ගානක් දෙකක් yeah thank you okay actually if you can feedback it is very easy okay I will do okay so which one you need this one this the question number 12 is it okay I hope others other question you can do by yourself because I have uh, up to 6 these are related with theoretical things okay so I hope you can refer your note and refer your textbook and you can answer the question okay and this one also we have done in one tutorial okay so you should be able to do this one and many examples we have done for this question number 7 it is related with the period of periodic signal so we have done many examples okay 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 so as I can remember I have also done similar example as this question number 10 okay and question number 11 I have done in one tutorial so okay I will do this question number 12 okay okay thank you for your feedback anyway okay so so here we are given a signal අපිට signal එකක් දීලා තියෙනවා no and okay you are given a signal so we will take the first one correct so it is the signal is what is the signal actually can you remember what is that signal can anyone tell me we have learned this signal under basic signals no what is this signal this is the signal no what is this signal yeah minus okay what is this signal can you remember can anyone remember I think before 15 minutes I have explained about this signal can you remember what is this yeah it is a deterministic signal thank you for that feedback your answer is wrong but this is a special function this is a special signal what is that signal we have learned this under basic signals what is the signal it is a real exponential signal no it is the real exponential signal and few modification has done okay but basically it is a real exponential signal. Okay. Okay. So I will start. Okay. So we are asked to find the odd and even component of this signal. No? අපිට කියන්නේ odd component එකයි even component එකයි හොයන්න කියලා. Okay. So can you remember the related identity with this odd and even component? Okay. So can you remember that if we tell like this, so this condition is for which signal? Is it for even signal or odd signal? Can you remember? And also we have this kind of signal, this kind of identity. Okay, this kind of condition, and this what is the for what signal this condition apply? This condition can be applied. So this is the even signal, no? This is even signal and this is odd signal. Okay, so if we get the time reverse signal and the time reverse signal is equal to the original signal, we called it even signal. Okay, and if we get the time reverse signal, so this is the time reverse signal x minus t, that is the time reverse signal. Okay, so under LO2 with the time transformation also you will learn more things about this. Okay, regarding with time reversal. Okay, so this is the time reverse signal, and if we get the time reverse signal and if we multiply it by -1, and if we get the same signal, original signal, we called it odd signal. Okay, so we have proved that sine is a even signal, sorry, sine is odd signal and cos is a even signal. No? Can you remember? Okay, so we have proved this. I have proved this in one of lecture. Okay. Okay, so this is the definition for even and odd signals. Okay, and also can you remember that any signal can be represented as a odd component and as a sum of odd component and even component. Okay, so this is another identity. Okay, so this is 1, this is 2, and this is the third one. Okay, so any signal xt can be represented as a sum of odd signal and even signal. Okay, okay, so can you remember? Okay, and also we can find the odd component or even component. Okay, so if I write the even component of any signal, we can find it using what is the identity? Half xt plus half x minus t. Okay, and also in the same manner we can find those component using half xt minus half x minus t. Okay, so this is the fourth identity and this is the fifth identity. So you should remember these 5 identity. Okay, related with odd and even signals. Okay, so if xt is equal to x minus t, that means the signal is equal to time reverse signal, we called it even signal. Okay, and if xt is equal to minus x minus t, that means if a signal is equal to minus, okay, minus of its time reverse signal, we called it odd signal. Okay, that is odd signal. And also we can represent any signal as a sum of the odd component and even component. Okay, and odd component can be evaluated. Okay, even component can be evaluated as by adding by adding the original signal and time reverse signal and get the half of it. Okay, and odd signal can be evaluated by subtracting the time reverse signal from the original signal and get the half of it. Okay, so these are the 5 identities. Okay. Now tell me which one we should use to find the odd and even component of this signal. To find the even component, what is the identity we should use? And to find the odd component, what is the identity we should use? Okay. So tell me, you can sell 1, 2, 3, 4, 5, 6. Okay. Up to 5. Okay. So for even signal, we should use one of these identity. And for to evaluate the odd component, also we have to use one of these identity. Okay. So can you tell me, to evaluate the even signal, what identity should we use? Please tell me. අපිට මේ සිග්නල් එකක් දීලා තියෙනවා. එයාගේ odd එකයි even එකයි හොයන්න තියෙන්නේ. odd component එකයි even component එකයි. හරි. එතකොට මේ විදිහට තමයි odd signal එකයි even signal එකයි define කරලා තියෙන්නේ. හරි. signal එකක් එයාගේ time reverse signal එකට සමාන වෙනවා නම් ඒ even signal එක. signal එකක් එයාගේ time reverse signal එකේ minus එකට සමාන වෙනවා නම් එයා odd signal එකක්. හරි. ඊට පස්සේ ආයෙ තියෙනවා ඕනම සිග්නල් එකක් අපිට ඔඩ් සිග්නල් එකක් විදිහටත් ලියන්න. ඕනම සිග්නල් එකක් අපිට පාර්ට් දෙකකට කඩන්න පුළුවන්. එකක් තමයි යාගේ ඔඩ් පාර්ට් එක. ඒකට අපි කියන ඔඩ් කම්පොනන්ට් එක. අනිත් එක ඉවන් පාර්ට් එක. ඒකට අපි කියනවා ඉවන් කොම්පොනන්ට් එක. හරි. එතකොට මේ දෙක එකතුවක් විදිහට ඕනම සිග්නල් එකක් අපිට ලියා ගන්න පුළුවන්. හරි. ඊළඟට ෆෝර්ත් එක ඊළඟට අපිට පුළුවන් ඕනම සිග්නල් එකක් දුන්නාම එයාගේ ඉවන් කොම්පොනන්ට් එක කැල්කියුලේට් කරන්න තියෙන්නේ එයාගේ සිග්නල් ඔරිජිනල් සිග්නල් එකට ටයිම් රිවර්ස් සිග්නල් එක එකතු කරලා ඒකෙන් භාගයක් ගන්නවා. ඒ වගේම ඔඩ් කොම්පොනන්ට් එක හොයන්න පුළුවන්. ඔරිජිනල් සිග්නල් එකෙන් ටයිම් රිවර්ස් සිග්නල් එක අඩු කරලා ඒකෙන් භාගයක් ගන්නවා. එතකොට මෙන්න මේ ඩෙන්ටිටි පහ ඔය කට්ටිය මතක තියාගන්න ඕනේ. අනිවාර්යයෙන්ම මේ ගාණක් එනවා ඔය කට්ටියගේ මිඩ් එක්සෑම් පේපර් එකට. හරි. මේ වගේ ගාන. එතකොට දැන් කියන්න ඉවන් එක මං හොයන්න නම් මෙතනින් පළවෙනි එකද දෙවෙනි එකද තුන්වෙනි එකද හතරවෙනි එකද පස්වෙනි එකද මම යූස් කරන්න ඕනේ. ඔඩ් කොම්පොනන්ට් එක හොයන්න කීවෙනි එකද යූස් කරන්න ඕනේ. ඒකට නම් I expect the answer, okay, because the answer is there, so you should be able to identify. So without the answer I can't move forward. I expect the answer from you. Okay, thank you. Yes, Ivan. Okay, to find the even component, what is the identity? What is the equation? So I have given 5 equations here. Okay, to identify, to evaluate this given signal, which one we have to use? Kokada we use karanna. Is it first identity, second identity, third identity, fourth identity, or fifth identity? Yeah, it is fourth identity, no? Yeah, thank you. So answer is there, no? So this is the expression to evaluate the even component. Okay, I have write it here. Okay, I have written it here. This is the identity to evaluate the even component. Okay, so we have to use this identity number 4, no? Evaluate the even component. Okay, So can you take 5 minutes and try to do this by yourself? So here the signal is given. Okay. Now our signal is given. Xt is equal to minus E minus T. Okay. And you have to get the time reverse signal. Okay. You have to get the time reverse signal. And you have to add them together and get the half. Okay. So using this identity, you can easily evaluate this. Okay. Oh, please get the expression for the given component. XCT. The XCT is equal to half XT plus half X minus T. Okay. So please find this answer. Please find this answer. Please take 5 minutes. Okay. And try to evaluate it. Yeah. If you want, you can discuss with your friend. Okay. Are you trying? Can you send me any answer? So you are given a signal, okay, and you have to evaluate the even component, okay, and to evaluate the even component, this is the expression, okay. So this is your signal. Xt is your signal, and X minus T is your time reverse signal. You have to add them together and get the half. So what is the expression for this? Right, tell me what is the difficult here? What is the difficulty in no. Tell me, so what is the difficult here to solve this? So what part is difficult for you? Okay. Which part is difficult for you? Okay, so this is, I think this is not difficult, no? Make him koi kalla hada ganna do katti kamal kiyanne xt kiyanne මේ signal එක. එතකොට මේ xt හොයා ගන්න එක පුළුවන්. xt කියන්නේ දීලා තියෙනවානේ මේ signal එක. එතකොට ඔයාලට අමාරු මේ කැලේ හොයාගන්න එක. time reverse signal එක මොකක්ද කියලා හොයාගන්න එක. දැන් මේක හොයාගන්න දෙයක් නැහැ මේක දීලා තියෙනවා නේ. එතකොට අපිට ඒක කෙලින් මෙතෙන්ට දාන්න පුළුවන්. So this is no need to find this component. Okay. So this part is given. Okay. This part is given. Okay. So we can so this part is given, that is minus c minus t. Okay. So this is the value for xt. Uttika, we will see. Actually, that is what I want. Okay. I don't care the answer is wrong or correct. If you can give me an answer, so that is enough. Okay. That is what I expect from you. Actually, I don't expect the correct answers from you. I just expect the answer. Whether is this correct or not, it is okay. Okay. So we will see your answer is correct or wrong. Okay. I hope it is not 0. Okay. We will see. Still, I am not sure. Okay. We will see. Maybe your answer is correct. Okay. So I think this part may be difficult to evaluate for you. Okay. But don't think too much. Okay. So you know that. So actually this is also the matter with the representation. Okay. This is also matter of a representation. So here you use t as the variable, as the independent variable. Okay. Okay. So if you use x minus t, now this minus t is your independent variable. Okay. This is your independent variable. Now it is minus t. So what you have to do is, instead of this t, you have to substitute minus t. This thing I have told you several times. No, we have done several examples. Okay. දැන් මෙතන t තමයි අපේ independent variable එක. මේක t වල function එක. t වල signal එක. t වල signal එක තමයි අපිට දැන් දීලා තියෙන්නේ. එතකොට xt අපි දන්නවා. ඒකේ මම ලියා ගන්න තියෙන්නේ. ඊළඟට අපිට හොයා ගන්න තියෙන්නේ x minus t. හරි, x minus t තමයි අපිට හොයා ගන්න තියෙන්නේ. ඉතින් මේක හොයා ගන්න යනකොට දැන් මෙතන මේ xt කියලා දුන්නාම t නේ independent variable එක. නේ? මෙයානේ independent variable එක. එහෙනම් x minus t කියලා දුන්නාම මෙයා තමයි independent variable එක. minus t. ඕනනම් මේ minus t කියන එක capital T කියලා හිතන්න. හරි. එතකොට මෙයානේ minus t කියන එක තමයි independent variable. Okay. So what you should do to evaluate x minus t? Simply you can replace this t by minus t. ඔකට්ටිය දැන් මෙතන x minus t නම් independent variable එක, මෙතන t වෙනුවට minus t කෙලින්ම දැම්මම ඉවරයි නේ. I hope you understand it. Okay. So that is actually independent. That is actually the time transformation. No? That is time transformation. So this is time reversing actually. Okay. So I will write it again. Okay. Otherwise you will get confused again. Okay. So I hope now you can understand what to do. Okay. So I'm going to do it at the beginning. I'm going to start it at the beginning. Okay. So this is the given signal. Okay. So this is the given signal, and to evaluate the given component, we have to add the half of our original signal and half of time reverse signal. Okay. So original signal is given, that is this. Okay. This is the original signal, E minus T. Okay, this is the original signal. And now you want to find the time reverse signal, this one. Okay, now you want to find the time reverse signal. Okay, so now so what should I do now to find? So xt is already given, that is minus E minus T. Okay, and we want to evaluate x minus T. Okay, so you can see that this is the independent variable T, but here the independent variable is transformed to minus T. Okay, so that is time reversed actually. Okay, so now this minus T is the independent variable. So what we have to do is, instead of this T, I can substitute the minus T here. Then minus into minus, that is plus, no? So I get x minus T is equal to minus E plus T. Correct? So do you have any question related with this? මේක තේරුණාද? මොකුත් නෙවෙයි ඔය කට්ටිය කරන්න ඕන. මේ t වෙනුවට minus t දාන්න ඉච්චරයි. මේක මොකක් තිබ්බත් මෙතන මේ මොකක් තිබ්බත් දෙකයි t මෙතන alpha වෙන්න පුළුවන් beta වෙන්න පුළුවන්. ඒකට transform කරන්න ඕන නම් කරන්න තියෙන්නේ දීලා තියෙන signal එකේ independent variable එක වෙනුවට අලුත් independent variable එක replace කරන එක. So did you understand that? I think all Anik, can you understand? I hope you can't understand Sinhala. Okay. Anyway, I will arrange one session in Tamil for you. Okay. I will get the help from your brother. Okay. The senior student. Okay. So anyway, if you have any question, you can always ask. Okay. Okay. So okay. So so I hope this up to this level you can understand. Okay, so what you have to do is, if you are given another variable, another independent variable, maybe alpha, beta, capital T, anything. Okay, if you want to transform it, okay, what you have to do is, instead of the original independent variable, you have to replace this. Okay. So here the t is our original, the given independent variable. Now we want to transform it to minus t. Okay. So instead of this t, so here instead of this t, I just put this minus t. I replace this t by minus t. Okay. So I can get the time reverse signal, or x minus t. Okay. So this is the first one. This is the second signal. So what you have to do now, you can easily find that component, even component, sorry. So that is half xt. Xt is nothing but minus e minus t. This is our xt, plus half x minus t. X minus t means this one. No, this is x minus t. So it is minus e plus t. Understand? So this is the answer. Okay. So if you can write this up to this level, I can give you the full box. Okay. Because I am not going to evaluate your mathematics knowledge here. Okay. You are doing signals now. You are dealing with the signals. Okay. So if you can find the signal up to this level, it is okay. Okay. But can you remember that at the very beginning, I told you that I hope we have already we have used this several times. What is called Euler formula? Can you remember the Euler formula? Can anyone remember? Okay. Can anyone remember? This is very important. Okay, this Euler formula. We are going to use this throughout our subject. Okay, when we are evaluating the Fourier, the frequency analysis things, we have to use this Euler formula. Okay, so what is the Euler formula? That is, I write it here again. So you have to remember this one. Okay, you have to keep remember this Euler formula. So if we have j theta, e j theta, we can write it as cos t plus j sin t. And if it is minus j theta, e to the power minus j theta, we can write it as cos t minus j sin t. Okay, so these are the two Euler formulas. E to the power jt, j is the complex part. Okay, so this is a complex signal. Okay, we can write it as two. We can write it as cos t plus j sin t. Okay, and e to the power minus jt also we can write it as cos t minus j sin t. Okay, so I can use this identity, this Euler formula, to simplify this much further. Okay, so we will do it. Okay, and you will get very important result actually. Okay, so we will see this. Okay, so can anyone apply the Euler formula for this and try to simplify this further? So shall I give you 2 minutes? Shall I give you 5 minutes? Can you try to apply the Euler formulas? Okay, so these are the Euler formulas I have written here. So can you give a try to evaluate, to simplify this further using the Euler formula, Euler formulas? Please try. I give you 3 minutes. Yeah, Nick. So this is also okay. Okay, but I want you to use this Euler formula. This one. This one. Okay. So I want to, instead of this e minus t, you can write this. You can use Euler formula and you can write it using cos and sine terms. And also this et also using Euler formula, you can write it as sine and cos term. Okay. Sorry. Yeah. Yeah, Nick, your answer is correct. Okay, actually, we can't use the Euler formula here. I'm sorry, I have done a mistake. Okay. Uh, so why we can't use the Euler formula? Actually, this is the Anik answer is correct. Okay. So this is the maximum level we can simplify this. Okay. This is the maximum level we can simplify. T plus minus T minus E T. Okay. So this is the maximum level we can simplify. We can't use Euler formula. Why? Because here no J terms. Here no complex term. Okay. This is complete real. Okay. For real exponential, we can't use the Euler formula. Okay. Only the complex exponential, the Euler formula is defined. Okay. So you can use the Euler formula in case of the complex form. Okay. Okay. So this is the even part. Okay. I think in the same manner you can find the odd part. Okay. So odd part. Okay, odd part is half xt minus x minus t half. Okay. So we have find this one and we have find this one. What we have to do is we can substitute. So xt is nothing but minus e to the power minus t minus x minus t is minus e to the power minus t. Okay, so this is the answer. Okay, okay, and checking. Okay, and checking uh, if you add this odd component and even component, check what is the answer. Please add this odd component and even component and what check what is the answer. Susanth, ඔයා මට කතා කරන්නේ. නුවන් සංජීවට කතා කරන්නේ. Hello. Oh, okay. Hello. නේ නුවන් මම නුවන් අත්තනායක. You should call to Nuwan Sanjeev. Okay, so so what is the answer you will get? Okay, so you have x odd signal, that is half minus e to the power minus t minus half minus e plus t, no? And your even signal is half minus c minus t plus half minus c plus t. So this is your even component and this is your odd component. Okay, so if you add this even component and odd component together, so can you tell me what is the answer we can get here? So you can see that this one and this one in same sign. Okay, so these two will be added, no? So we will get minus e to the power minus t, e to the power minus t. Okay, and you can see this is minus and this is minus into minus. That means this is plus. Okay, and this is minus. So you can see that this part and this part cancel out and this is 0. And what is this? Minus e to the power minus t. What is this? That is your xt, no? The given signal. Okay, so can you see? If you add the even component and odd component together, you will get again the original signal, the given signal. Understand? Okay. Okay. So I hope that question is clear for you. Okay. Then I will do the next one. Okay. So this is the answer. This is the question. No? How can I take it? I can't copy it. Okay. So I will write it by minus t to 0. Okay. I will write it. So this is the signal. Okay. T plus 1. The t is between -1 to 0, and it is 1 to 0 to 1, okay, and 0 otherwise. So this is the signal, no? This is the signal given. This is the signal given. So let's verify it again. So here t plus 1, -1 up to 0, 1, 0 to 1, here 0 otherwise. Okay, I'm correct, no? Okay. So okay, this is equal and this also should be equal. So we have to, so this is the given signal. So we have to find the odd and even signal. Okay, odd and even signal. So you will get this type of question in your mid exam. Okay. So okay. So you can see that in this case we are not going to draw the signal. Okay. In this case we are not going to draw the signal because the even signals and odd signals we can find using the identity. Okay. Actually, this is a continuous signal. Okay, this is a continuous signal. Normally, we know that we are learning about continuous signal. Okay, we are learning about continuous signal. Okay. So if you see this, okay, if you see this, this is also continuous. This is also continuous. Okay, so this is also continuous. Okay, and you can see that here there are three parts: this part, and this part. Okay, so this is a continuous signal, and you have three parts. We normally call it three pieces. Three pieces. Okay, so this is one piece, and this is another piece, and this is another piece. So it is three pieces. We have three pieces here. Okay, so we normally, so these three pieces, all pieces are continuous. So normally we refer this type of signal as piecewise continuous. Piecewise continuous. Okay, so try to remember this term. Okay, so this type of signal are piecewise continuous. Okay, for piecewise continuous, it is very hard to analyze using the expression actually, because we have three expressions. Okay, so the analysis is much difficult. Okay, but in this case, this all the signals are the total signal is continuous. It is not a piecewise continuous. Okay, so this signal is not a piecewise continuous. Okay, so we can use that analytical method. Okay, we can use the identity and we can find the answer. Okay, but for this signal, this is not a this is not a complete continuous. It is a piecewise continuous. Okay, so for piecewise continuous, it is difficult to evaluate using only that identity. This is the identity for a component, and we have identity for even component. Okay. So here it is xt plus, xt minus x minus t, both divided by half. And for even signal, it is xt plus x minus t. And the addition should be divided by half. Okay, so this is the even part, odd part, and this is the even part. Okay, we have to identify, but for this signal, it is hard to use this identity itself. Okay, it is very difficult. So what we have to do is, okay, so first we have to draw this signal. Okay, we have to draw this signal, and also we have to draw the time reverse signal, and we have to add them together and get the half. Okay, that is the easiest way. Okay, so the first thing you should do is you have to draw this signal, draw the signal, and also you have to draw the time reverse signal, and then you can add up them together or subtract one by one, and you can find the odd and even component. Okay, so that is the method. That is the easiest method rather than using this identity itself. Okay. Okay, so first, can you draw this signal? Can you give a try to draw this signal? Now, at this point, you should be able to draw this kind of signals. Okay, so please try to draw this signal. Okay, actually, that is why I given you that tutorial. If you see this tutorial, if you can't draw this type of signal, you should tell me, I can't draw this signal. I can't draw this type of signal. Okay, I am sure that most of you can't draw this. Okay, maybe one or two students will do it, but I think most of you couldn't do this. Okay, I know it, but you should ask from me. That is why I have given you a tutorial. You can use it at a guide. So you can see there, you have to draw the signal. So you should be able to draw it, no? Draw any signal, given signal. Okay. So, okay, anyway, first you try, then I will explain how to draw this kind of signal, okay? So please try to give a try to draw this signal. Okay. So you have to use three pieces. This part is applicable only t within -1 and 0, and this part is applicable when the t is between 0 and 1, and this part is applicable in other cases. Okay, so try to draw this signal by yourself. So we have half an hour remaining, so I will give you around 5 minutes. Please think, at least no need to draw. Please think something. Please get the start somehow. Okay. Okay, I will give you 5 minutes. Okay. Try to think about how to draw this kind of signal. It's very important to draw this kind of signals. Okay. Actually, you can use MATLAB to draw this. Okay. You can use MATLAB to draw this. Okay. So if it is online signal exam, if you draw this through MATLAB, I will accept it. Okay. But if it is not, if it is a physical exam, you can't use the MATLAB there. No? So you have to do it by your hand. Okay, please try to do this. I will give you 5 minutes, another 4 minutes remaining. Think about this. සිග්නල් එක ඇඳ ගන්න පුළුවන්ද? ටිකක් හිතන්න කොහොමද අඳින්නේ කියලා. think Please think how to draw this kind of piecewise continuous signal. So this is very important. This type of question will come to your exam. Okay. Okay, I will do. I will do it. Okay, please try to understand. Okay. So as I told you, so you have, so here this is a piecewise continuous signal. That means we have several pieces. Okay, we have several pieces here. Okay, so this is our first piece, second, and we have another piece. Okay, so we will get the first. So how to draw a signal? So normally you should draw, basically you should draw the independent variable line and dependent variable line. Okay, like this. Okay, and this is our independent variable. This is our dependent variable. Actually, this is the signal. Okay, this is a signal. Okay, so we have this signal. Okay, now if we consider the first part, okay, if we consider first part, that is t plus 1. If we consider the first part, the second part, the first part, it is xt is equal to t plus 1. Okay, so and also t is between minus and 0. So t is in minus and 0, minus 1 and 0. Okay, so what is this mean? What is this mean? I think this you can understand. This means t is greater than minus 1. That means t is greater than minus 1. That means this side. No, this side. And here it is said that t is less than or equal to 0. That means from here. Okay, less than means here. So the t value should be minus 1 and 0. Correct? Okay, so t value should be minus 1 and 0. Okay. So you can see that t value is minus 1 and 0. That is for this part. Okay, first piece. That is for first part. Okay, t value is, so t values are here. Between, those are between minus 1 and 0. Okay, so whatever the signal related with this t plus 1, we get within this range. Okay, we get within this range. Okay, so you can see that this is xt is equal to t plus 1. Okay, so what you have to do is when you draw a signal, okay, so you I think you have learned this. This is like mx plus c type signal. Okay, so this is a linear signal, linear graph. No, okay, you will get a line here. Okay, you will get a simple line. Okay, so you know that to draw this signal, we have to substitute some value for this t. Okay, so here we have range. So I substitute this minus 1 and 0 for t. Okay, so if I substitute minus 1, what is the xt value? Tell me. If I substitute the minus 1 here, what is xt? Please tell me. I need the answer quickly, otherwise I will not proceed. Okay, please soon. So instead of this t, I should substitute minus 1. So what is the value? Please tell me. Quick. I need the quick response. Respond. Yes, thank you, Oshan. It is 0. No? So here it is 0. So at minus 1, it is 0. Okay. And now if we find this one, t is at 0. Okay, so now t is at 0. Okay, so xt is equal to t plus 1. What is the answer if t is at 0? What is the value for xt? Yes, thank you. It is 1, no? It is 1. So when the t is at 0, the yt xt signal will be 1. Okay, so I think no need to find other signal, other point. Okay, if you want to find the between point, let's say it is minus 0.5. You want to find the point between 1 and 0, middle point, that is at t is equal to minus 0.5. So what is the answer? What is the xt? So actually this is not no needed. Okay, this point no needed. It is enough these 2 points. Okay, but if you want to find another point to verify your answer, what is the xt? Instead of this t, you have t is equal to minus 0.5. Okay, so instead of t, you should apply minus 0.5. So what is the answer? Yes, thank you. It is it is 0.5, no? Okay, so here at this point it is 0.5. This. So you know that t plus 1, it is y equal mx plus c type signal. That means it is a line. Okay, so you will get a line from here to here. Okay, so this is the piece. This is our first piece. So now the second piece. If you consider the second piece, second part, now we have the range t should be greater than 0. That means t is this side, greater than 0. And t should be less than or equal to 1. And t also should be less than 1. That means this side. So the t for this second part, what is the t range? It is 0 to 1. No? T range is 0 to 1. Okay. So 0 to 1, what is the value? Xt is equal to 1. So what is this actually? I have given a name for this. What is this? We called it a special name. It is a special component actually. What is this? So we call this a DC component. No? Can you remember? In last class we learned this. It is a DC component actually. DC part. That means the value is not changing. It is a constant. Okay. So 0 to 1, it will be like this. No? This one. Okay. This will be 1. And otherwise, that means this level and this side, it is 0. So no signal, no, it is 0. So this is our signal actually. So we have drawn our signal. Okay, so this is our signal. Okay. Okay. So now we have to find the time reverse signal. No? To evaluate the odd and even component, we have to draw the time reverse signal. So this is our original signal, xt. Now we have to find x minus t. How to find this? Okay, how to find this? So this is time reverse signal. Okay, so we have learned that when we are evaluating the time reverse signal, it is the mirror image on this y-axis, on this independent variable axis. If we get the mirror image of this signal on this y-axis or independent variable axis, we can get the time reverse signal. Okay, so we have to consider this piece by piece actually. Okay, so if I consider this piece 0 to 1, what is the mirror image? So we have to consider this as a mirror. No, we have to consider this as a mirror. So mirror image will be, you will get like this, no? This is the image for this signal, for this part, okay? So you will get, here it is 0 to 1, minus 1, you will get this kind of part, understand? So this is the reverse signal, okay? So this is the reverse signal. So this is the reverse signal, okay? And if you consider this part, okay, how to get the mirror image for this part? Consider this as a mirror. Make a kannadiyak කියලා හිතන්න, හරි? Consider this as a mirror. kannadiyak කියලා හිතන්න. Okay? Then you have to get the image. Okay? For if you keep this kind of line in front of a mirror, what you can see? You can see this kind of reflection, no? You can see this kind of reflection. Okay? So here it is minus 1 to 0, and this reflection will be 0 to plus 1, no? Because it is in this side, correct? Okay, so here this is 1, so you will get this kind of signal, this kind of part. This is 1. Okay, so is this okay for you? ඉස්සෙල්ලාම මේ කෑල්ල time reverse signal එක කියන්නේ exact x y අක්ෂයේ independent variable line එක අපි හිතනවා mirror එකක් කියලා. mirror එකක් කියලා හිතලා යාගේ image එක ගන්නවා. හරි? එතකොට ඊට පස්සේ මේ කෑල්ල image එකේ, එතකොට එහෙම කරනකොට මේ කෑල්ල image එකේ එන්නේ මේ පැත්තටනේ. මෙයා කන්නඩියක් කියලා කිව්වොත් මේ පැත්තට මේ විදිහට අපිට පේන්නේ. මේ විදිහට අපි මාකයි line එකක් තිබ්බොත් එතකොට මේ part එකේ image එක මෙයා කන්නඩිය කියලා හිතුවොත් මේ විදිහට එන්නේ. හරි? එතකොට මේ විදිහට. Okay? Did you understand, Anik? You understand? I think other should understand, because others can I hope other can understand in Sinhala. Okay. Okay, thank you, Anik. Anyway, Anik, if you have any problem, you can mail me, okay? Because I don't know the Tamil, that is why I couldn't explain it in Tamil, okay? Anyway, I will arrange one student to do a 2-hour session for you, okay? For you guys, the Tamil person, okay? Okay. So this is our time reverse signal, okay? Now what we have to do? Okay, we have to add this signal and this signal together. No? We have to add this signal and this signal together. Okay, and we have to get the half of it. So that is our even signal. Okay, and to find out signal, we have to subtract this signal by this signal, the time reverse signal from the original signal, and we have to get the half. Okay, so that is the normal procedure. Okay, so I will do it. Okay, so you can see that. So actually you can do this using the MATLAB also. Okay, very easily. Okay, but to do it by manual, it is somewhat hard. Okay, so you can see that. Okay, so you can see that. See here, minus infinity to minus 1, here it is 0, and also from minus infinity. So I will get the full page, okay, otherwise it is hard to tell. Okay. I will draw it very small, in small scale. Okay, so this is our original signal. Okay, this t and this is x. This is our time reverse signal, x minus t. Okay, so we have the image for this part. It is like this. Okay, up to -1, and image for this part we will like this. It will like this up to -1. Okay, this is 1. Okay, okay, so this is 1 and this is -1. Okay, so these are the two signals. Now I want to add them together. So if I add them together, okay, if I add them together, okay, so that is x t plus x minus t. Okay, so I need to draw this x t plus x minus t. Okay, so how to draw this? Okay, so you can see that if we consider this one minus infinity to up to -1, it is 0. And here also minus infinity up to -1, it is 0. So for this one, minus infinity up to -1, it will be 0. No change. Because 0 plus 0 is 0. Okay. Okay. Now if you consider this point, okay, if you consider this point, you can see that this point the value is 0, but this point the value is 1. So you will add 0 plus 1. Okay, so the answer is 1. So you will get 1 here. Okay, so this point will move to up to 1. Okay, okay, and if you consider this half point, so this is 1 point. So this is, can you remember that this is 0.5? Actually, you don't need this value. Okay, but to get more idea, but to get more clear picture, I will use this point also. So this is 0.5. Okay, this is 0.5, and here it is 1. Okay, at this point, so here it is 0.5. You will get minus 0.5. You will get 0.5, and minus here for this one minus 0.5. You will get 1. Okay, so you can see that 0.5 plus 1. That means 1.5. So you will get 1.5 here. So this is 1 and this is 1.5. Right. This here. Okay. I will use this one up to here. Okay, so this is t. Okay, and this is, we are going to draw xt plus x minus t. Okay, so you can see that up to -1 the value is 0, but at -1 the value will be 1. Okay, so point is here, and also in 0.5 value is, I will use another color. The value is 1.5. The value is 1.5. This one. Okay, and if you consider this point, 0 point, so this one also 1, and this one also 1. So that means 1 plus 1, that is 2. So this 0 point, this the sum signal will be 2. No, okay, so you will get is like this. Okay, and what about this? If you get this one and this one, so the same thing you will get. No, here it is 1 and here it is 1, so you will get 2. Okay, and if you consider this 0.5 point, here it is 1 And if you consider this 0.5, it also 0.5 here. So here 1 plus 0.5, you will get 1.5. No? So at 0.5, you will get 1.5. Okay. And for this point, here it is 1 and here it is 0. So at 1, t is equal to 1. Here it is 1 and here it is 0. So 1 plus 0. So 1 plus 0, you will get 1. No? So you will get 1. So it is at t is equal to 1. Okay. So here it is t is equal to 1 actually. Okay. T is equal to 1. Okay. So you will get this kind of signal. Correct? So this is your xt plus x minus t. Okay. So please try to understand how to go this. Okay. Do this by yourself and try to get to understand it. Then you will be able to understand this. The thing is that you should do this by yourself. Okay. If I do 1,000 of example like this, you will not get the idea. If you do 1 or 2 question, 2 exercise by you, you will get the idea. Okay. Okay. So you will get this kind of signal. Okay. So to evaluate the even signal, what you have to do? You have to get the half of this signal. Okay. You have to get the half of this signal. And so you can see that after 1 up to infinity, this is 0, this is 0. So 0 plus 0, you will get 0. That means no signal. Okay. So signal is up to this level. Okay. So you have to get the half of this 2 signal. No? Xt plus x minus t. So if you divided this signal by 2, what happened? The amplitude will be reducing. No? Okay. That is amplitude descaling actually. Okay. Don't confuse the word. Okay. So this 2 will be 1. Okay. And this 1 will be 0.5. This will be 0.5. So your signal is like this. This is minus 1 and this is plus 1. This is 0.5. This is 1. If you divided this point will be 1 and this point will be 0.5. So it shrink actually. Okay. When you learn the time scaling, you can see that if we do time scaling, the time is shrink or the signal is signal will be compressing, no signal will be expanding on y-axis, on x-axis, on t-axis, on the independent variable axis. Okay. Same way, when we get the amplitude descaling, that the signal is spreading or signal is expanding, spreading or shrinking. Okay. No need to think those things. Okay. Just forget. Just take the idea. This 2 when you divided this by 2, because you have to get the half. Okay. So this 2 should be divided by 2. You will get 1. And this point also should be divided. 1 should be divided by 2. You will get 0.5. So you will get this kind of signal. Okay. So what is this? This is the even part. No, this is the even part. Okay. And to find out part, what you have to do? You have to subtract this signal from this signal. Okay. You have to subtract from this signal from this signal. Okay. So so try to do that subtraction by you. Okay. Subtraction by you. Okay. And try to find the odd component. Odd component. Okay. Please try these things at your home as exercise. Okay. So I will stop here. Okay. But I hope you will do this. Okay. So you will do the subtraction. Okay. In the same manner, you have to do. You can do it. You can consider this point here. The 1 should be subtract from the 0 should be subtract from 1. So you will get -1. Okay. And 1 should be subtract from 1. You will get 0. So you will get the signal -1 to 0 like this. Okay. And if you do the same thing for the plus direction, you will get same signal like this. Okay. And you have to get the half of this signal. Okay. So please try this by yourself. Okay. And if you can't do this, you can ask me. You can send me an email, or you can ask me this in next discussion. Okay. So I hope you can do this. Okay. So I will sketch it. Okay. So you have, I will write the both signal together. Okay. So you will have this kind of signal, and also you will have this kind of signal. No? This kind of signal. Okay. Now, if you subtract, here it is 0. This is your original signal. Okay. The violet color one is your original signal. So here it is 0 and here it is 1. So you have to subtract 0 from 1, no, 1 from 0. That means you will get -1. So this point will get -1. Okay. And if you subtract this, here it is 0, here it is 1 and 1, then you will get 0. So you will get this kind of part. Okay. And here again, this is 1. Okay. This is 1 and this is 0. Okay. Then you will get this kind of, no? This kind of part up to here, up to this. Okay. So you will get this kind of. Because here it is 1 and 0, so you will get this kind of signal. Okay. So this red color one is your signal if you draw this. Okay. And if you get the half, this also will be half and this also will be half. So you will get here it is -0.5 and here it is +0.5. So here it is 1, -1, and here it is +1. So you will get a signal like this. Okay. So this will be your signal. Okay. I do it quickly. Maybe I have done a mistake, but anyway, you can verify it. You can verify it. Okay. The thing you should do is that you have to do this by as a homework. Okay. Okay. I hope you can do this. Okay. So this is actually half. You can spend half an hour for this kind of question. Okay. Within half an hour, you should be able to solve this kind of question. Okay. Okay. So we will wind up. Before winding up, you can ask any question if you have. So here we have evaluated odd and even component of a signal, and also we have learned about the piecewise continuous signals. Okay, and also it is a new concept for you, I hope. Okay. So shall we wind up if you don't have any question? Okay, then we will wind up. Thank you for your participation. Okay, thank you.